Hi class, we are continuing our notes with quadratic equations. This time we're going to write an equation in standard form when we have the given roots. So let me explain this to you in a way that you have already done something similar to this in finding the roots. When we have an equation in standard form like x squared minus 5x plus 6 equals 0. This isn't in your notes, so just watch as I go through this. When we had to do this, I told you to find the roots. So what you did is you went factoring in x and x minus 3 minus 2. And then you said each factor equal to 0. So x minus 3 equals 0 and x minus 2 equals 0. And then you added 3 to get x equals a positive 3 and added 2 to get x equals a positive 2. So you already know how to do this. So this is, given the standard form of an equation, find the roots. Now we're just going to do this in the exact opposite order. So we're going to be given the roots. We are given these two things. And we want to find the standard form of an equation. So this is going to be our answer on these type of problems. We want to get the standard form of an equation. So we're just going to work backwards. We're going to go to this step. Once we're to this step, we're going to go to this step. And once we're to this step, we're going to get our answer in this step. So let's just quickly see how that would look on this problem. Once again, you don't have this in your notes, so just watch as I do this. Our roots are x equals 3 and x equals 2. So now, to go to this step, we want to get a 0 on the right side of our equation. So that means I'm going to subtract 3 and subtract 2. So x minus 3 now equals a 0, and x minus a 2 equals a 0. Alright, once we're to this step, now we're going to move to this step. So how do we get to this step? We just put both of those factors, we multiply them, and equal it to 0. So x minus 3 is one factor, x minus 2 is the other factor, we set it equal to 0. And then lastly, to get our equation, how do we do that? Well, we simply FOIL. We multiply these two binomials by each other. So when we multiply, we get x squared minus 2x minus 3x positive 6. That equals 0. And so our answer, x squared minus 5x plus 6 equals 0. Here's the standard form of an equation, which is what we want. We want to find the standard form of an equation when we're given the roots. And these were the roots that we were given. So that's what we're going to be doing for these four problems here on this day of notes. So let's look at this first one. Our roots are 1/2 and a negative 5. So when we look at our graph, it crosses at a negative 5 and it crosses at a positive 1/2. There's our negative 5, there's our positive 1/2. So when we say our roots, we say that's what x equals. X equals 1/2 and x equals a negative 5. That's going to be the first step with all these problems, so please write that down. Now what we want to do is we want to get a 0 on the right side. Pay close attention on this first one. You could say, let's just subtract 1/2, and you would be right. But let's get rid of our fractions by doing this. Let's multiply this by 2. And so then we would get 2x equals 1. And now let's subtract 1 from both sides. And now we would get a 0 on the left. So 2x minus 1 equals 0. Okay, that one's done. And now this one over here is quite simple. All you got to do is add 5. So x plus 5 equals 0. So we got 2x minus 1 equals 0. And we have x plus 5 equals 0. Now, these are two factors that we can multiply by each other. 2x minus 1 multiplied by x plus 5, that equals our 0. Now to finish this one off, we're going to FOIL. So first times the first, 2x squared. Outside term is 10x. Inside term is a negative x. Last term is a negative 5. Combining like terms, 2x squared plus 9x minus 5 equals 0. 2x squared plus 9x minus 5 equals 0. This is your answer for this one once you get it into standard form of a quadratic equation. If you wanted to, class, you can put this in your calculator under y equals, and you would get this graph. It would cross at 1/2, and it would cross at a negative 5. Might be a good idea if you want to check your work that way. Let's now try number 5. Why don't you guys pause the video and try this one on your own. We're going to set both of these equal to x. So x equals a negative 1/3 and x equals a negative 2. We're going to multiply this one by 3 to get rid of our fraction. So 3x equals a negative 1. Then we're going to add 1 to both sides. So 3x plus 1 equals a 0. And then for our other factor, it's x plus 2 equals 0 when we add 2 to both sides. So now that we have our factors, let's multiply them by each other. 3x plus 1 multiplied by x plus 2 equals 0. Now we're going to FOIL these and get our standard form of an equation. So 3x squared plus 6x plus 1x plus 2. That equals 0. Combined like terms, our answer for a standard form of a quadratic equation is 3x squared plus 7x plus 2 equals 0. And once again, class, if you wanted to, you could put this in on your graphing calculator, and when you do that, you would get a graph that looks like this. Crosses at a negative 2, which is this point right there, and crosses at a negative 1/3, which is right there. Number 6, it's a double root, which this is where it doesn't cross the x-axis, but it hits the x-axis at a negative 4, negative 1, negative 2, negative 3, negative 4, right there. So when we have this, it means that x equals a negative 4 twice. So make sure you write that down twice. X equals a negative 4 and x equals a negative 4. So now when we set them equal to 0, it's x plus 4 equals 0 and x plus 4 equals 0. So both of our factors are x plus 4. X plus 4 times x plus 4 equals a 0. FOILing this, we would get x squared plus 4x plus 4x plus 16 equals 0. So our standard form of an equation would be x squared plus 8x plus 16 equals 0. And we're done for that one. Our last problem, definitely the trickiest one of the day. Pay very close attention to this. Our roots are 1 plus 2i and 1 minus 2i. These are what you called conjugate roots, imaginary conjugate roots, because one is a positive and one is a negative. And whenever we get imaginary roots, they will always come in complex conjugate pairs or imaginary conjugate pairs. So we see this and we still want to get the standard form of an equation. Now a standard form of an equation isn't going to have any i's in it when we're all done. So that's a great way to check our work. We should never have any i's when we're all done with getting our standard form of an equation. So we're going to do this the same way we did the past 3. We're going to set these equal to x. So one of our roots is x equals 1 plus 2i. The other root is x equals 1 minus 2i. The next step is going to be the same as the past 3 problems. We want to get a 0 on the right side. So let's subtract 1 and subtract 2i. So x minus 1 minus 2i equals 0. Subtract 1 and add 2i. We're going to get x minus 1 plus 2i equals a 0. The next step is the exact same as the past 3 problems. We're going to get both of these factors and multiply them by each other. So the first factor is x minus 1 minus 2i. The other factor is x minus 1 plus 2i. All of that equals 0. Alright, so now in the past 3 problems, once we've gotten to this point, we've multiplied a binomial by a binomial. Now we're going to multiply a trinomial times a trinomial. It's definitely more work, but it's something that can certainly be done. Just make sure this is multiplied by the whole trinomial, the second term is multiplied by the whole trinomial, and the third term is multiplied by the whole trinomial. So every term in one trinomial has to be multiplied by every term in the other. So let's first distribute this x to all 3 of these terms. Here we go. We have x times x, which is x squared. X times a negative 1, which is a negative x. And x times a positive 2i is a positive 2ix. It looks weird, but that's how we're going to write it. So now our middle term, our negative 1 multiplied by x is a negative x. A negative 1 times a negative 1 is a positive 1, and a negative 1 times a positive 2i is a negative 2i. Okay, and now our third term. So a negative 2i multiplied by x is a negative 2ix. A negative 2i times a negative 1 is a positive 2i. And then a negative 2i times a positive 2i is a negative 4i squared. That equals a 0. Oh man, I said in our standard form that we wouldn't have any i's. Look at all these i's that we have right here. Let's see if we can get rid of some of them somehow. Notice how 2ix minus 2ix, boom, is 0ix. So those two terms cancel each other out. They disappeared, they are gone. That's very nice. Here we have a negative 2i and a positive 2i. Boom, that makes 0 i's and they cancel each other out. Isn't that wonderful? This is all good news. And now I have this I squared. Reminder from chapter 5, what does I squared equal? It equals a negative 1. So bam, that I is out of the question. Now it's a negative 4 times a negative 1. So this whole thing right here turns into a positive 4. So we have an x squared term right here. We have a negative x and a negative x to make it negative 2x. And then we have this positive 1 and this positive 4. That equals 0. Whew! So our final answer in standard form, x squared minus 2x plus 5 equals 0. And there's our answer for problem number 7. X squared minus 2x plus 5 equals 0. If you wanted to check this one in your graphing calculator, you could somewhat, in knowing that if we get complex conjugate roots like this, it means that our answers do not cross the x-axis. So you could put this into your calculator, y equals x squared minus 2x plus 5, and if it doesn't cross the x-axis, you're on the right track to checking your work to make sure you did it right. So definitely a tricky one. Let me know if you have any questions on that when you get to class tomorrow.